What's up, Algebra 2? Welcome back to my YouTube channel. Today we'll be reviewing reflections, stretches, and compressions. So go ahead, take out your notebook and something to write with because we're going to take some notes. I'm going to piece out in this little box right here. Alrighty, guys. So if at any point in the video you need to pause, rewind, and rewatch, please feel free to do so. I know this is going to go by a little fast, but just bear with me. Okay, so we're going to start off by summarizing reflections. And for this example, we'll be looking at f of x equals 2x minus 6. Hopefully you'll see that and recognize that it's a linear equation. So here it is graphed, and I've gone ahead and labeled the points because that's going to help us later. Okay, so now let's take a look at reflection. One of the reflections that we can do to this is if we put a number in front of our f of x. So we're going to look at y equals a times f of x, specifically y equals negative f of x. So what that actually does is because the negative sign, the a, is outside the parentheses, it actually affects our outputs. So because it affects our outputs, it's going to be a reflection over the x-axis. So this point right here, 0, comma, negative 6 actually becomes 0, comma, positive 6. That's a typo right there. Okay. This point 1, comma, negative 4 becomes just 1, 4. This point 2, negative 2 becomes 2, 2. Okay. Now let's take a look and see what happens when we put a b inside of our parentheses. So we're going to look at the reflection y equals f of b times x. So specifically, y equals f of negative x. So let's see what that does. Okay, so because the negative sign, the b this time, is inside our parentheses, it's going to affect our inputs. And so because it affects our inputs, this ends up being a reflection over the y-axis. So this point right here, 4, comma 2 becomes negative 4, 2. 3, 0 becomes negative 3, 0, and so on and so forth. Okay, let's shift gears a little bit. And this time we're going to be summarizing stretches and compressions. And for this example, we'll be looking at the equation f of x equals the absolute value of x. And you can see that I've already graphed it. We've got that V shape and I've labeled the points. So let's take a look and see what happens when I specifically plug in the number 3 in for a. Okay. So what that does is it's going to give us a vertical stretch. So I've got the original absolute value graph, which is graphed in purple, and then the result when I put the 3 in front of our f of x. So that's the red graph, the red absolute value graph. And we can see that that's a stretch. So our graph gets skinnier. And because, again, it's outside of our parentheses, it's going to affect our y values. So this point 1, comma 3 becomes 1, 3. This point 2, comma 2 becomes 2, 6. All of those y values got multiplied by 3 and they were stretched upward. Okay, so we can summarize that by saying when the absolute value of a is greater than 1, it's a vertical stretch. Now let's take a look and see what happens when I plug in 1/2 in for a. So when I plug in 1/2 for a, it's still going to affect our y values, but this time we're going to get a compression. So it's going to make our graph wider, and we can summarize this by saying when the absolute value of a is less than 1, that's what's saying in green right here, then it's a vertical compression. And we can see that on our graph as well. So for example, this point, negative 2, comma 2 became negative 2, comma 1. The thing that changed was your y values. Okay, again over here, this point 2, comma 2 became 2, comma 1. All of those y values were compressed. And you can see that by the arrows that I'm drawing in the graph. Okay, now let's take a look at horizontal compressions. So horizontal compressions are when I put a b inside my parentheses. And so this time we're going to plug in a 2 in for b, just like it's written right there in orange. So when I put in 2 in for b, what's going to happen is we're going to get a horizontal compression. Okay, so because it's inside the parentheses, your inputs are going to change. So this point, negative 2, comma 2 became negative 1, comma 2. And we can see that your y values didn't change, but your x values did. Same thing with this point on the other side. So this positive 2, I don't know why that says negative. That should say positive 2 became positive 1. So it got compressed, and you can see that by the orange arrows that are drawn in the graph. Okay, let's take a look at a horizontal stretch of 1/2. So this time we're going to replace the b with a 1/2. And again, there's the original graph, the original absolute value graph, and it's in purple. And this time what happens is we get a horizontal stretch. So it moves in the direction of the pink arrows. And we can summarize this by saying when the absolute value of b is less than 1, we get a horizontal stretch. Okay, guys, I know this went by a little fast, but it is a summary, and we'll get into greater detail about what these things actually do. Thanks for watching.